Okay, uh, today we are going to see about complete Prometheus. In the last class, we were seeing about Elm and Argo CD. So I hope you have tried something and you got some good familiarized about some Elm and Argo CD and why the Elm is being used. uh, Elm, why we call Elm as a package manager. So by using Elm, we deployed custom charts and then we deployed some applications in Argo CD by using the Elm chart as well. So today's class is completely about Prometheus. So so what is this Prometheus? So this Prometheus, we are going to install this Prometheus by using the same Elm, but this Prometheus is kind of an metrics tool. So when it comes to monitoring, there are two types of monitoring that in general you should take care. So the first thing would be like logs. Logs means when you run some application, it will print some logs. Okay, and the second thing about metrics, what we call as logs. The logs, whenever an application runs, it prints some statements. If in your application there are some print statements will be there, it will be print that. So that we call as logs. Metrics means I am running my pod, so there will be some CPU allocated for this pod or some memory allocated for the pod, so or some disk size will be there. So and we the pod status, these things are we mostly called as metrics. So this Prometheus that we are going to see only to monitor the metrics. Okay, log part we will come later. When we see the cloud part, we will be seeing some services in native services in the AWS itself. So we are going, most probably if a pod goes down in the Kubernetes cluster, by using this Prometheus tool, we do this general monitoring. Obviously, there are plenty of tools others in the market. This Prometheus and Grafana were used in most of the organizations. So let me deep dive. So whatever if you are there's a Kubernetes server, when you install Prometheus in there, it will scrape all the data, scrape all the metrics like the CPU, the memory, and the pod status. So everything it will be scraped, and it Prometheus will keep it in a time series database. Time series means at what time, at this particular time, this pod was running. At particular time of them, CPU was consumed this much, so it will keep all them in a time series database. So mm, that's what this Prometheus means, and it works on the pull based architecture. So it's a Kubernetes cluster, right? So it obviously need to scrap the data. Kubernetes doesn't have to push any data when you installed Prometheus as a CRD. So what is you can ask me what is this CRD? CRD means custom resource definitions. So this is part of Kubernetes itself. When in Kubernetes, what are the native components we see like deployments? We have seen services, and then we were seeing pods, right? But if you are planning, you have some third party tool and you want to deploy them by using LM charts and as a Kubernetes resource, you have to go with this custom resource definitions. Most of the third party tools were installed in the Kubernetes by using this custom resource definitions. For now you just understand about these things, that's fine now. So and it works on the pull based architecture. For now you can just learn about that. And if you see the Prometheus architecture, so these are the main components. So the first main component will be your Prometheus server. Yeah, Prometheus similar to the Argo CD, you will be seeing a Prometheus server UI where you will do all these configurations and you run this PromQL. You might have heard of SQL, like structured query language. So similar to that, in order for you to run some query in the Prometheus, there is something called PromQL is there. PromQL means Prometheus query language. So it has its own syntax and everything. You no need to worry about or mug up any PromQLs here. You can just have to know some basic things. Rest you can do some googling or use ChatGPT, or you can like go through the online documentation. That will be fine. So The first main component will be like Prometheus server, okay, which will be like your UA, and then there is something called alert manager, because when you scrap some metrics from the Kubernetes, like it is my Kubernetes cluster, consider it as my Kubernetes cluster, you obviously scrap, Prometheus will scrap some data, and there will be something called alert managers will be going to sit. If any pod goes down in the Kubernetes cluster, then by using this alert manager, we are going to shoot out email to you. You will shoot out email, and then we will send it to Slack channel or some Teams channel. So those things will be taken care by this alert manager. This Prometheus server where you have this time series database, and one more main component would be like node exporter. When I told Prometheus, it's a monitoring tool, it scraps metrics. So in Kubernetes cluster, we have different worker nodes, right? So we have to know, right? We have to monitor each and every node, right? So these data will be scrapped by the node scraper. That is called, we call as node exporter. And the fourth component would be like kube state metrics. So if your pod is running inside the node, to scrape the data from the pod, you will be having something called kube static metrics. So you can just consider only these four main components for now. uh, Prometheus is a open source time series database tool which is used to scrap metrics, and you will be having an UI for that to access the Prometheus, and there is something called alert manager to send alerts to email or Slack channel or Teams, and the fourth will be like node exporter, and then the fifth would be like kube state metrics to scrape the metrics from the Kubernetes services. So for now, you just know about these four major components. Obviously, there are some few other components are there. We needed to no need to worry about those things. You just understand about these four main components. So if you see my PPT, so I mentioned these things: Prometheus server scrap metrics and stores, time series database, exporter exports metrics, and then alert manager alerts, take care of this emails and alerts. So these are the main components. So you can see a flow here, right? um, Maybe if you are my diagrams, if you don't understand, you can see here an exporter will be there. This exporter will be running in the Kubernetes. It will send the data to Prometheus. Prometheus will send the data to Alert Manager. Alert Manager will take care of sending the emails or alerts to the Slack channels. And we'll using Grafana to visualize this thing. So whatever we going to see in Prometheus, we obviously will be having in UI, but it's we are not able to see what pod is running, what is the current CPU, everything. So it's not a visualization, it just scraps the metrics. So let me go and try to install the Prometheus in my local. First let me mm, so I'm using the same command. I'm first using lm repo add Prometheus community, and then the URL where this Prometheus chats are available. uh, Now I'm going to do lm repo update. After you install any repo, always do repo update. If any new version has been released, it will be get down, you will get those informations. Successfully got Argo chart repository, successfully got an update for Prometheus community as well. Now my repos got updated. So now I'm going to install the Prometheus chart. So mm, the command is the same. So what I'm going to do is like I'm going to do elm install Prometheus. I'm giving a chart name as a Prometheus, and in the Prometheus community I'm going to install the kube Prometheus stack in the namespace iPhone monitoring, and I'm giving a flag like create namespace. If it doesn't exist, it will create it. And I entered. mm, I think my minikube is not running. Let me start the minikube. Yeah. Yeah, I think I have to start my mini cube again. Let me start it. It's taking some time to start the mini cube. Let me wait. Ah, my mini cube started. I'm going to do the element install Prometheus now. So it started to install the Prometheus that. Hmm. Now if you check LM list hyphen monitoring, you can see the Prometheus stat has been installed successfully. If you do lm list hyphen monitoring, a Prometheus stats are installed, and if you run the command kubectl get all hyphen n monitoring and hyphen l means the label. So by default, whatever the release name that you give, it will Prometheus will add those tags. So I'm just checking for the resources whatever this Prometheus has been installed. Uh, oh, uh, I know the issue. It's like capital A. Let me type the command. It's some copy paste issue. kubectl get all hyphen and monitoring. Ah, this is fine. Uh, so these are the resources that has been installed by the Prometheus Elm chart. You can see straight away if you go to the pods, you can see yeah, alert manager Prometheus pod has been running and a Grafana pod has been running. You will be seeing that as well. And then Cube Prometheus operator has been installed and Cube state metrics has been installed and then Prometheus Cube this is the main Cube Prometheus server and one more node exporter has been installed. See, these are the components that we actually installed: the node exporter, kubestate metrics, Prometheus server, alert managers, and you can see different services has been running and different deployments were there, and obviously some of them are being installed as a stateful states here. If you see kubectl get stateful sets hyphen n monitoring. You see, alert managers and Prometheus servers are installed as an stateful sets. Set in last class we have seen what why the need of stateful set is like it has to store some data, right? That's the reason we have to use stateful sets. If your application is stateless, if the thing there is a requirement to store any data, then it should have been a deployment itself. That's the reason this Prometheus server has been installed as a stateful sets. So now what I'm going to do is like I'm going to export this Kubernetes service. Wait. So you see a Kubernetes server here, right? I'm going to export that now. by using the command. uh, oh, it seems it's already exist. Wait, let me show it. I tried a demo. Now what I'm going to do is like, so when we were running this kubectl get all command, we were seeing the Prometheus cube Prometheus, right? Uh, this the service. I'm going to expose them as a node port, and then I'm going to connect from the browser. Okay. So what I'm going to do here is like kubectl expose service. This is a service. It's running in the monitoring namespace, and the type is node port, and the target port is 9090. That's where the default the Prometheus will run, and I'm giving the service as name like Prometheus server ext. Okay. After you done, so this Prometheus Prometheus server has been exposed as a node port. If you type kubectl um, get services hyphen in monitoring, you'll be seeing a new services now, Kubernetes service external. Now this cluster IP resource has been exposed as a node port, and it has been running in these nodes. So either if you after your service has been exposed, either you can do the kubectl port mapping, if or you can use some Kubernetes native commands, sorry, mini Kubernetes commands like a mini kube service. So this command is to I'm using it in locally to expose this Kubernetes server. Even though I have exposed as a node port, there are some firewall rules that blocking my uh, application. So that's the reason I'm using this command. If you are using Minikube in your Windows, similarly you have to use this thing. You have to add Minikube service and the service name which you want to be exposed. Once you run, it will be exposed the application in some particular random port. You see my application is started to run here now. If I go to my browser, um, now you see this to 127.0.0.1 is my local host, and it's been exposed in this particular port. Now you see this is how the Prometheus UI is going to look. Yeah, we will run some queries. If you run some up command here, up, and then you execute, these are, you see it started to scrape some details from the different Kubernetes resources that has been deployed now. You see jobs like Prometheus cube, Prometheus operator, cube state metrics, Prometheus cube, Prometheus. So you somewhere heard these job names, right? When we were seeing, it was started to scrape the details from its own components. When we were, like you see, hmm. So these are the services, right? It These services has been exposed here. So when I run the up command, it will show me what are the services that been running here. So that's why you see all the default and the own Prometheus components here. So let's go to deploy some application, and we will see whether we are getting this scrape metrics here or not. Mm. Before that, I just wanted to give brief about these exporters. Because it's a pull-based architecture. You want to expose different metrics from different areas. If you use node exporter, node exporters are used to export the logs from the node level, from the machine, from the physical machines. So if you type after the Prometheus URL, So what we have here, right? I just copy it and new open a new tab and slash metrics. You see what are the metrics in default. This Kubernetes, this Prometheus grabs. You can go through a complete list here. You see Prometheus HTTP request duration seconds. So these are the different type of queries for are you available here. Uh, Whatever the up command which I run here, these are the different types of queries that you can get it in the default itself. For all these default metrics, Prometheus already creates its own alerts and everything. If you go to alerts and then you see some of the default alerts here, like alert managers, some config map, some etcd. These etcds are like Kubernetes main components. So you can see some of the inbuilt alerts are already there, and like Kubernetes, sorry, Prometheus started to scrap those details as well. Now there is something called kube state matrix. By using this kube state matrix alone, it started to scrape those details of the Kubernetes native components. And this C advisor, it is runs on top of kubelet. It runs on the node level. And custom app metrics, when you have a custom application, like you have our application is running on like in Java, Node.js, or in .NET, how I should expose those metrics. There is separate way is there that we will be seeing. And if there is any third party exporter, if you are using any Kafka or Cassandra from the third party tools, how I'm going to export those logs as well. So these are the different types of exporters that are natively available for you. Now what I'm going to do is like I'm going to deploy application and I'm going to scrape those details. Before that, so I was talking about some CRD, right? So let me open a new tab. I do kubectl get CRD. CRD means custom resource definitions. You see now new resource has been created, right? So when I installed this Prometheus, it created different CRD. CRD means custom resource definitions, like alert manager is there, Prometheus is there. uh, it creates its own kind of definition. If I run kubectl get Prometheus, it's not a native component. I know it's actually deployed in monitoring workspace. You see a Kube Prometheus server has been installed. If you go through this, I'm typing it as a YAML. So I want to see this file configuration. You see this file has its own definitions. It has API version v1. Some items are there, like monitoring core is there, and it has its own metadata section, and it has its own label section, and it has its own spec and affinities. So what you have to consider is like, if you come down, there is something called pod monitor and service monitors are there. Mm, Pod monitor and release monitors are there. What are these pod monitors and service monitors? So when I installed Prometheus, so by default it created some CRD, right? And it is labeling some pod monitor and service monitor. In order for your application to scrape the details, you have to create either this pod monitor or service monitor. Pod monitor, both the resources are same, but pod monitor will scrape the details only from the pod level. Service monitor means it will scrape the details from the service level. When we create deployment and then there will be service, right? Based on the tags in the service, it will scrap the details. But pod means it will directly scrap the details from the pod. That's a simple difference between this pod monitor and the service monitor. So just consider a flow. You have an application here. Consider any application like some Nginx or your custom app or anything. Then you must be having some labels. You must have some labels. That label should be matched in the service monitor. So the service monitor will scrap, like you consider like app nginx. Okay, consider like app nginx. While you create this service monitor, this label should be present there. So it will automatically scrap the details from the Nginx pod to either the service monitor or the spot monitor, and it will send to the Prometheus server. So this how the general scrapping will occur. Now we will be seeing two examples. One example is like if I my application like if I use Nginx, obviously there will be no exporters will be there. If you see my deployment YAML file here, so let me close everything. Hmm. So I have a deployment file here. This is the same deployment file that we've been used in the previous classes, but the extra item would be like I am going to run it two containers. So mostly everywhere to scrap the metrics from a single pod. In each and every case, when we were talking about pod, there will be only one container that was running, right? In the previous cases, but in the real-time world, it's not the case. There will be multiple containers running in your same pod. The first pod is considered the main container would run your application. So if your application is running, you have to get some details from the application for monitoring purpose. So, like in parallel in the same pod, one more container is to go run. This is not your end application. This container is used to scrape the details from the container from the main container and collect all the metrics and send it to some exporters. That's the reason of this second container. So we mostly call it a sidecar. SIDECAR. We call the sidecar containers. So that's the reason we run the sidecar containers. Now if you check my deployments file, so I'm having a Nginx exporter because Nginx is a inbuilt application. I cannot customize anything there. So if Nginx is running on some it's running by using this Nginx exporter, this Nginx Prometheus exporter alone, I have to scrap the details. So what I'm passing here is like I'm giving these Nginx exporter image. I'm going to run it as a sidecar, and I'm giving some passing some arguments. This argument is similar to CMD in Docker file. I'm setting the URL where it has to send. So, and one more thing is that I'm creating a empty volume here. So I'm just mapping some Nginx configs here. So this Nginx configs will make the application, like whatever the Nginx application running here will make adapt the application to send the details to this Nginx exporter. You don't need to be understand this main level. What you have to understand is like if you, in order to scrape the details from the Nginx, like some third-party tools, you must be having some exporter related to that. There's some Prometheus exporter. It should be available there. So and I'm having a creating a service here. Okay. Now because all the applications that we run in Prometheus, it will scrape the details from the slash metrics, whatever the application will be, like one or two three, like whatever the pod will be. It is like Java application, it is like Python application, it is like some .NET application. So all these application should expose their metrics in the slash metrics API. Okay, if it doesn't expose the API in slash metrics, Prometheus will not know there is some data exist in the pod or not. So for custom application, we will see how to scrape those details. For the inbuilt third-party application, you have to use this node exporter, and then you have to create the service. So why I'm creating a service here? Like I am planning to um, like scrape the details from by using the service monitor. Okay, the service monitor means in the service monitor is labeled as app nginx. So similarly, my deployments also have the same labels, but it is going to scrape the details from the service level. Now if I go to my bash, hmm, let me redirect to my Prometheus and default nginx kubectl apply -f, and then I give the deploy svcm. So this file completely contains about it has some deployment file, and then it has some config maps get mapped to the application to send the metrics to the Nginx exporter, and then it has some service. So when I run this thing, so I'm creating everything in the default namespace. If you type kubectl get all, you will be you will be seeing this deployment. You see two containers are started to run, and this is a nginx service. So now if you go to the next file, the service monitor, so the API version is like monitoring.course os.com/v1, and the kind is service monitor, and I'm giving the name as nginx service monitor, and the namespace is monitoring namespace. I'm not going to install in the default namespace. I'm going to install the service monitor in the monitoring namespace, and I'm giving a labels as release Prometheus. So this is the important section. Okay, so when uh, what I'm showing you, like kubectl -n monitoring get Prometheus. When I typed get Prometheus, this was the service Prometheus kube Prometheus Prometheus. It was running there. I'm exporting as a YAML file, and I'm grouping the service monitor selectors. By default, what happened? The service monitor selectors matches the label called release.prometheus. So if you create any service monitors, it should have these labels as well. Okay, what I told when in the slide. So my application is there. It is going to export the log metrics in slash metrics API. So yes, a service monitor has to be deployed, and it has to carry the label what this Prometheus server has been having here. So if you edit this file, like if you edit this Prometheus service, and if you wanted to add some other labels, you can add it. If you not, you just use the default label itself. That's how when you create the service monitor, this Prometheus server will know I have to scrape the metrics from here as well. Now and then you see the selector is equal to this label that we give. So the Prometheus will know this is falling under my control, and then these labels like app nginx, it will be scrape the details from that particular service, and then the namespace is in default, right? So I'm giving the match label as app nginx, and it has been deployed in the default metrics, and the port is metrics. So if you take my deployments, I'm exposing I'm opening two ports here. The first port is 80, the second port is like naming it as a metrics, and I know this node exporter is going to export the logs in the port 9113. Okay, so now what I'm going to do is like I'm going to create this service monitor as well. kubectl um, deploy apply -f, and then service monitor. If you do kubectl get service monitor, so these are the inbuilt service monitors that are available when Elm chat has been installed. This is the service monitor which I installed now. Now what I will do is like I will go to the UI, and I will try to run some commands. So I'm duplicating this tab. So we know there are some alerts is there, some query tab is there. So instead of alerts, if you put targets after whether you are scraping the data or not. So if you put targets, you can see a lot of targets are there. These are the targets where it started to fetch the metrics. If you see, um, now I created a service model called nginx service monitor, and there is something called this inbuilt Prometheus components are there. Prometheus kube Prometheus alert manager, API server, core DNS, those things also will be present in the targets. This latest service monitor which we created, and you see it is giving two IP address. If I go here and then type kubectl get pods in the default namespace -o wide means it will give extra details. You see, I have deployed two pods and it is running with IP like ends with 10.244.0.195 and 194. So these are those pods, and it is exporting the logs in 9113 by using the node exporter, and it exposing the logs in slash metrics in slash metrics API. Now you can see it my targets has been added here. Mm, Now I go to this expression, and then if you type some promptqls like up nginx, because we know it is a service level monitor and my service name is nginx hyphen service. You can see nginx hyphen service, and then if you execute this thing you will be getting the same thing. Whatever you have seen these details, you will get the same thing. This is the promptql that we will be writing. You can up command, we know up command just tells whatever the service is they're running. This job I equal to nginx service is just a filter we update there to check whether what where the application is running. For now you can just know about this, and then if you do some other queries are as well, like if you do some count, like it will just give you like number of counts there. So obviously there will be some table section is there, graph section is there. Here we don't have any metrics to see the graphs. That's fine. Let's move to some custom app scraping here. Um, so this is the default nginx application. I started to scrape the details, but what if in case you write some application? So here consider, hmm, I have some app.py, right? So this is a custom application. So it is running with by using some flash modules. So here, if you see this py file, it exposing the logs in slash metrics, and obviously it is importing a Prometheus client library. So if it is your custom application, instead of we have seen like if it is like a third party tool like Nginx or something, if I have to scrap data, you in the deployments you have to run a sidecar as a node exporter, and then you by using the service monitor or pod monitor you scrape the details and you push it those metrics into the Prometheus server. That's how we have seen now. This is the custom app. If your application is there and if you want to expose those metrics, what you have to do is like you have to import this library called Prometheus client for each and every language in Node.js or .NET. It will be this library name or this installation methods will going to differ, that those developers will take care. But you have to know this Prometheus client library should be installed, and it has to expose those metrics in slash metrics folder. Then only Prometheus will know, it will scrap those details. Okay, I'm just having an app.py file, and then I have some requirement.txt file where you have to hold the dependencies Flask and Prometheus client. And if you check my Docker file, it's just a simple Docker file. I have the Python 3.10 slim version, setting an app directory as the working directory, and then copying the app.py and requirement.txt file inside the Docker file, and then run this pip install and then start this Python application. Okay, now uh, I have shown you demo about service monitor. Now I'm going to give a similar demo with pod monitor. By using pod monitor, I'm going to scrape those details. Okay, what I'm going to do is like first, for me to build this application, first I'm going to build this Docker image. Okay, let me redirect to custom Python app. I'm giving the application. I'm like, uh, I'm giving the image tag as custom metrics slash r, and the tag is latest. I'm building the image first now. When I do Docker images now, you can see this custom metrics has been builded here. Now what I'm going to do, I'm using a mini cube, or if you're up and I'm not going to push this image to somewhere else, so that's the reason I'm going to run one more command called minikube image load and the image name, because if I try to execute my deployment straight away, it will give me like image pull error, because minikube is not able to find this custom docker image. So once you I build this docker image by using the docker commands, I'm going to do some minikube image load and the image name which I have. So it will make the image will be available inside the minikube as well. Now what I am going to do is, like, now I know this image is available. If you see my custom deployment file, mm, you see this is the same deployment, it has the same configuration, but I'm naming it as a custom app. I'm giving the labels and the pod labels and the deployment labels as custom app. Here you see I mentioned my custom image here. The port is I'm mentioning as a HTTP 8080, because I know my application is going to run on edge port number 8080. But I'm not giving the node exporter, because it's a custom app. In the inbuilt the application itself push the metrics in slash metrics API. I no need to give any node exporters here, and I'm creating a service for this one. No, not any. It's just a usual file. But it's a custom application I'm going to install. Now I'm going to do kubectl apply -f and then custom deploy services. So I'm deploying these services and deploy. If I do kubectl get all, you see this custom deployment is been started to run here. The pods are running and the service has been created. Now I'm going to use the pod monitor. See, if you see the both the configurations, like the pod monitor and service monitor, both the things are same. Service monitor will scrap the details from the service level. Pod monitor is going to scrap the details from pod monitor. Rest the all the templates, all the specs are the same. API version is still the monitoring coreos.com /v1. Kind is pod monitor. I'm giving a name as custom app monitor. Namespace is in monitoring. The labels is release Prometheus. So when I was so this Prometheus CRD version, if you see, there is something called pod monitor selector as well is there, and service uh, monitor selector as well. Both matches the label release Prometheus. So it is already present there, the pod monitor labels. So that's the reason I'm using the labels as release, and I know my custom application has the tag as custom app, and it is installed in the default metrics. And I know it has a port run, which I named as HTTP, and it has to scrape the details from the slash metrics API. Now I'm going to run this pod monitor as well. Now if you check kubectl get pod monitor -n monitoring. See, a custom app monitoring has been deployed now. So and it is started to scrape data. How I know it is scraping the data or not? If you go to this slash targets and if you do refresh here now, mm, wait, it's taking some time to get reflect there. Let's wait. It's deployed like 51 seconds now. Mm, kubectl reports. Yeah, it's everything is running. Kubectl. Ah, now you see. Previously, this only the service monitor was there. Now a pod monitor for custom app has been added, and it is, if you see the IP, like it is like 10.244.0.196. If I check kubectl get port iPhone O wide, hmm, it started to scrape the details. You can see my custom app has been started to run in the IP which ends with 196. If I go now by using the same commands, um, what I'm doing, I'm just using the same command up, and my pod is like it should contain the name called custom app. If you execute that, it might be, wait. Hmm. You see, now it came. It took some time to came here. You will be seeing the same details whatever we seen in the targets. So that's about this custom monitoring. Uh, for now, I think this is fine. Uh, so we will be in the next class. We'll be seeing about this alert manager. So if I start this alert manager, it would takes uh, some solid time. So I don't want to do that. So in the next class, we will be setting up this by using this alert manager. If for one of the application, we are going to send an email, and then we will be starting the Grafana as well. So Grafana, by using Grafana, we can do different steps. But what we are basically going to cover is like we will try to run the Grafana, and then we will be setting some default dashboards, and and we, if possible, we will try to modify some, create some custom panels as well. So that's what I plan for Grafana. So I am ending this class now.